Okay, guys, welcome back. Today we're going to review a bit for the upcoming quiz. So we're in the last two pages of the packet on review 6B, 7A, and 7B. Don't worry about the first section here. We're not going to quiz on that. We'll exclude it for this video. You guys just had an Ed puzzle, and we'll just leave it at that. So, not sure how much I'm going to get through, if I'm going to get through all these review problems, but we'll see how time goes. Okay, number 5, we have to simplify. We have the square root, so that's an invisible index of 2, an even numbered index. So that means we're supposed to use the rule here that the exponent and index cancel out. And since it's an even numbered index, you're supposed to get the absolute value of the radicand. So the absolute value of -9 is 9. Number 6, again, square roots. We have two parts here. The first part, square root of 49, is 7. And then the 2's cancel out for the x, so 7x. Number 7 is fourth root of 81. I'm going to take 81 and break it up into a factor tree and try to get a 4 of a kind for the index of 4. So 9 and 9, 3 times 3, 3 times 3. So I actually do have a 4 of a kind here. The fourth root of 81 is actually 3. 3 to the fourth power is 81. Now, for the z, the rule is you're supposed to take the exponent and divide it by the index. So z to the 16 divided by 4 is 4. Since there was no remainder, you don't have a radical anymore. Everything worked out perfectly. Okay, so square root of 350. So I'm going to break down 350 using a factor tree, and we're going to try to get 2 of a kinds. So that could be ends in 0, 10, and 35. 10 is 2 times 5. 35 is 5 by 7. So we have a 2 of a kind here, so that means a 5 comes out. The 2 and the 7 must get put back in and multiplied to make 14. And just a forewarning on your quiz, I need to see factor trees. I need to see work shown. You cannot just give me your answer and expect credit. I need work shown for problems like 7 and 8. You know, your bigger numbers that you're finding the radicals for. Number 9 is multiplication. So let's multiply a square root times a square root. Since they're the same radical indexes, we are allowed to multiply their radicands. So square root of 4 times 20 is 80. And then y to the 8th carries over. And then z to the 2nd times z to the 2nd, we're really adding them to get z to the 4th. Remember, when we multiply, we're really adding the exponents. All right, so square root, index of 2. So I'm going to break down 80 and try to get 2 of a kind. So that could be 8 and 10. 8, 2 times 4. 4 is 2 times 2. 10 is 2 times 5. So let me highlight my prime numbers here. Sometimes I like to circle them if they're on paper, because you don't want to not see one of them. Okay, so we need 2 of a kind. So we have a pair of 2's and another pair of 2's. So 2 times 2 will be 4 outside the radical. And then this 5 gets stuck in the radical. And then we'll move on to the exponents. So for the y, 8 divided by 2 is 4. There's no remainder, so y is not in the radical. And then z, 4 divided by 2 is 2. Z also does not have to be in the radical because there's no remainder. So there's your answer. Let me just shorten up that radical, make it look a little cleaner. So right here is your answer. Okay, number 10. I can't divide 125 divided by 16, so it looks like I'm going to have to take the square root of each of those later, probably in the second step. Now take a look at your variables. I'm not good with words today. So what you can do is reduce the fraction. I'm just carrying over my regular numbers. Now, a to the third divided by a to the first, we can divide that. We're really subtracting the exponent. So 3 minus 1 will be 2. So a to the second on top, there's no more a on the bottom. And then the b's, b to the 6th divided by b to the first. That's 6 minus 1 is 5. b to the power of 5. See, it's nice to reduce fractions before we worry about square rooting. Okay, so now let's go ahead and take the square root of each of the numbers. Let me do 125 on the side. That would be 5 and 25. 25 is 5 and 5. So we have 3 of them here. 3 5s, but we only need 2 to come out because it's a square root. So we got a pair. A 5 is going to come out. This 5 gets stuck in. And then also we can work on the denominator. Square root of 16 is 4. No more radical in the denominator. And now we want to work on the variables. Since it's square root, for the a, the 2's cancel out, so it's a to the first brought outside. And then for the b, 5 divided by 2 is 2 with a remainder of 1. When you have a remainder, it goes back inside the radical. And we don't need that 1 there, so we'll get rid of it. We don't have exponents of 1 in our answers. All right, even though that thing seems uglier than the original problem was, that is considered to be simplified and finished. That fraction cannot reduce any further. Nothing can divide with that 4. Okay, now we move on to subtraction. In order to add or subtract, the radicals have to be like radicals, meaning they have to have the same index, which they do here. They're both square roots. However, they also have to have the same radicands, which they do not. This has an 18, this has a 2. So, you cannot subtract at this moment, but you should always try to simplify the radicals, and a lot of times they will end up being like radicals after you pull something out. So that 18, let's bring it down to the side and see what we can pull out. So 2 times 9, 9 is 3 times 3. So it's a square root, so that's 2 of a kind. So a 3 is going to come out. It's going to multiply by that 6 that's out there already to get 18. And then this 2 does not get paired, so it just the 2 stays in, the radical. And then look, when I bring that down the 4 root 2, they are like radicals now. They both have a square root of 2, so we are allowed to subtract their coefficients. So we're doing 18 minus 4 is 14 times the square root of 2 is your answer. Number 12, we're pretty much going to do the same thing as number 11. At first glance, we cannot add and subtract, but we need to try to simplify first and see if we can get like radicals. So let me pull 32 to the side. That could be 4 times 8. 4 is 2 times 2. 8 is 2 times 4. And 4 is 2 times 2. So we have a pair and another pair, and this guy will get stuck in the radical. So 5 times a 2 and another 2, and that squared 2 gets stuck in the radical. So 5 times 2 times 2, that's 10 times 2 is 20 root 2. Again, I need to see this work shown on your quiz to receive credit. Okay, now we're going to break down the 8. So 8, 2 times 4. 4 is 2 times 2. So a 2 comes out. This squared 2 stays in. So that'll be plus 6 times 2 that comes out, root 2. So plus 12 root 2. And then now the 18. 18 is 2 times 9. 9 is 3 and 3, so 2 of a kind. A 3 comes out, this 2 stays in. So minus 7 times the 3 that comes out, root 2. Minus 7 times 3 is 21 root 2. All right, now take a look. The radicals are the same. They are all square root of 2, so they're all like radicals. So I can do 20 plus 12 is 32. Minus 21 is 11. So my answer is 11 times the square root of 2. Number 13, again, is a problem that you need to show your work. Okay, so here, looking between the parentheses, you will notice there's nothing. That implies multiplication. So we have a binomial times a binomial. We're going to have to FOIL here. So first times first, that's the square root of 4, which is 2. The outsides will be root 2 times root 5 is plus square root of 10. The inside will be minus, because a negative times a positive. Root 5 times root 2 is root 10. And then the last, a negative times a positive. And then square root of 5 times the square root of 5 is the square root of 25, which is 5. So after that, you will notice that these guys cancel each other out. Plus square root of 10 minus square root of 10 is 0 root 10, so get rid of them. 0 times square root of 10 is 0. And then we're left with 2 minus 5, which is negative 3. Number 14, the exponent of 2 outside means you're supposed to write it twice and FOIL. Okay, so square root of 6 times square root of 6 is square root of 36, which is 6. Then the outside would be positive times negative. And square root of 6 times the square root of 3 is square root of 18. By the way, that's a minus 1 root 18. Hint for what's coming up next. And then inside, negative times positive is negative. Root 3 times root 6 is root 18. Don't cancel them off. They're both minus. And then the last, negative times a negative is a positive. Root 3 times root 3 is the square root of 9. Square root of 9 is 3. So don't cancel the 18s. It is negative 1 minus 1. That'll be negative 2 times the square root of 18. Also in the same step, I'm going to do 6 plus 3 to get 9. Now, please do not subtract these. Do not put a 7 here. That 2 has a radical. 9 does not have a radical. They are not like terms. We cannot subtract them. However, we can clean up the square root of 18. We can simplify that. We've done it already today. Square root of 18 is 2 times 9. 9 is 3 times 3. So since it's a square root, 2 of a kind, a 3 will come out. And this 2 stays in. So times 3, root 2. And then 2 times 3 will get your 6. So there's your answer. 9 minus 6 times the square root of 2. Number 15, looks like I'm foiling again. There's nothing between the parentheses. So let's multiply these out. Now, when we're multiplying, there's a 1 out in front, always. So we can do the numbers out in front, multiply them together, and we can multiply the radicands together. So 1 times 2 will be 2, and then the square root of 5 times root 5 is square root of 25, which is 5, so it becomes 2 times 5, which is 10. Now move on to the outside. So 1 times 3 will be 3, so plus 3. Square root of 5 times square root of 6 is square root of 30. Believe it or not, square root of 30 cannot be simplified. If you take a look, that's 2 times 15, and 15 is 3 times 5. There's no 2 of a kinds there. All right, so let's just carry this down with the 10, line it up. Now let's multiply the insides. Negative 3 times 2 is negative 6. Square root of 6 times the square root of 5 is square root of 30. And just bring that down to line it up. And lastly, the last, negative 3 times 3 is negative 9. Square root of 6 times square root of 6 is square root of 36. Square root of 36 is 6, so it's minus 9 times 6, which is minus 54. Okay, now let's get to our answer. Combine like terms. 10 minus 54 is negative 44. And then the 3 minus 6, we're going to subtract those because they both have the square root of 30. So 3 minus 6 is negative 3. So we write minus 3 times the square root of 30, and we must stop there. Okay, number 16 switches it up a bit, goes to section, I believe it's 7B, where we are going back and forth between radicals and exponents. So make sure we're reading directions carefully here. We're converting to radical notation. So the 4 of the denominator will be the index. So it's 4th root of y to the 3rd. So please remember the denominator is always the index. Number 17, first things first, we got a big no-no in math here. We are not allowed to have negative exponents. So what we need to do is make a fraction, move 12 to the denominator, and make the 1/4 positive. Now we can convert it to radical form. So again, still make it 1 over. There's nothing on top, so you got to put a 1 to represent it. And then the 4 is the denominator, so 4th root of 12. 12 to the power of 1, but don't put the 1 for the exponent. Okay, number 18. So first thing I notice in this problem again, similar to 17, is I have a negative exponent, so let's make a fraction. C will stay on top. The D has the negative, so it moves to the bottom. Okay, now we can turn them into a radical. Now we can actually make one big radical with a fraction in it. The reason we're allowed to make one big radical with a cube root is because both of them have denominators of 3. So then the C to the 4, power of 4, and D to the power of 2. Number 19, they both have a denominator of 4, so we can make it 4th root of, and then simple, r to the 6th, s to the power of 5. Very simple problem when you have common denominators and you're turning into a radical. Okay, next up, number 20. The directions say convert to exponential notation. So 15 to the power of 3/4. The 4 is the denominator. The index is the denominator. 21, also very easy. 21 to the power of 5/6. Number 22, however, not so easy. We have the fifth root of the square root of 12. So let's convert, we have a radical, a square root inside of another radical. So let's change them each into exponents, and then what we're going to have to do is multiply the exponents. So if you look at the inside, the square root of 12, we know that's 1/2. Remember, square root is 1/2 as an exponent. Then we have the fifth root of it. The fifth root would mean 1/5. And there's an old exponent rule that you've been learning since 9th grade that says when you have an exponent to another exponent, it's called a power to a power, and you are supposed to multiply them. So we do 1/2 times 1/5, and that is 1/10. Okay, I'm looking at my time. I'm a little restrained here. I'm going to finish with 23, but as always, if you guys need any further help on 24 and through 28, you can always ask me during class or the Zoom session. Okay, so let's do this. If I'm converting to an exponent, let's change them both to exponents right away. So the first one would be 6 to the 1/3 power times, it's a hidden multiply, 6 to the power of 1/4. Now if we have 6 times 6, what are we supposed to do with the exponents? We're supposed to add them. So we're going to do 1/3 plus 1/4. I don't have a calculator, so I'm going to make common denominators when you add fractions. So 3 and 4 has a LCD of 12. So the first one multiplies both numbers by 4. The second multiplies both numbers by 3. And now we're allowed to add to get 7/12. That is my answer. All right, guys, study up. I hope this video helps you guys a bit to get a good grade on the quiz. Take care. Have a good day.